Hello everyone, today we will understand the pre-processing of data. Why pre-processing of data is required? Let us relate the data to our natural resources. The natural resources are always not in the purest form or in the form that we need. If we take gold, it's actually not in the form of gold. It's kind of having impurities over it. It has dirts over it. It has other elements being mixed into it. But we are converting or we are changing that resource to our requirements. We are converting and changing the resources to our requirements. The same way, the data that we actually fetch from other resources or when we manually take out the data that we need are not always in the purest form. They do have some mistakes or errors, or it's not in the particular format that we need, but we have to convert that data into our needs. We have to convert all this data according to our needs. It's really necessary, and that process is known as the pre-processing. So let us understand how this pre-processing occurs through a simple data set over here. So we have a weight, height, and gender CSV. So it's a sample data set which has 19 columns, 19 rows and 3 columns over here. The 3 columns are gender, height, and weight. Over here, if we see here, we could find certain values are missing, and also we could find this the gender column having a string values and not numerical values. We have to work on it because if we see with string values, we know that computer doesn't understand what string value is. It doesn't it doesn't know what actually the male means, what female means. It doesn't know what it is. So we have to convert the string value into a numerical value. So that thing we are going to see, and how we are going to handle those missing data over here, we are going to understand it. So let us get into the code. So over here we have used the Python programming language, where I've used the IDE Jupyter Notebook, and let us get into the how the code works. So while handling this data, it is required that we need to be working on with certain packages, and the packages that we are using over here are pandas and numpy. So pandas, we used it for working on the data frames or the data sets that we are going to get into this program, and we have this numpy, which is actually stands for numerical Python, where we are going to operate, or we are going to work with the numerical operations. So instead of pandas, we are using the whole world pandas as PD, and if we see about numpy, we are going to use it as NP. So let us get into the code. So we have the data set weight and height.csv, which is in the comma separated value format. We are going to get that data set into our Python program. So how we are going to do is, we are going to place this whole data set into our variable, that is the data over here. As highlighted, we could see that this variable, we are going to store all the data that is being said in the kept in the data set. So how we are going to do it? So here we have the pd.read csv, which is nothing but pandas.read csv over here. So in this particular package, we have this function called known as read csv. We are going to read the complete data set, and we are going to store it in the variable known as data. So when we run this cell, we could find the data over here. So we could find the same data that we have seen in the in this way. We could find the same thing over here also. So we have male, female, and we have the height and weight, which has certain NaN over here, which is nothing but not a number, which stands for not a number. NaN stands for not a number. So before getting into this data, we need to understand what are the things required to we need to know what this data is actually saying. So for that thing, we have this function known as describe, which actually describes statistical values, or how much the maximum, mean, standard deviation, minimum number. We could also find all those numbers over here. We could find those statistical values over here. As we can see, the count, number of rows, number of columns over here, number of rows over here, and we could see mean, standard deviation, with the minimum value, the maximum value. We could all find those things over here. And we also need to understand what kind of data types are used in the columns, or that also we could find over here using this function known as the d types. So here we could see the height and weight are being used, float is being used, and for gender we are used object, that's nothing but the string values. So right now we can understand what data is actually saying. So right now we need to see where are the null values being present. So for that thing we are using this function known as data.isNull, which the isNull is the function over here, which actually returns a boolean value. So if it is true, if the value over here, we could see here, we could see a lot of false here, and we can see only few trues over here. So if the particular cell is not having any data, it would return true, and if the data is present over there, it will represent as false. So over here we could find that the false is the things that where the data are present, and we can see very few true values over here, where which represents the values are not present. That we could if we want it to be easy to understanding it, we could see the data set over here where we could see certain values are not there, which is being represented in an. So over there it is being it is returning true over all those places. So this is what the main function this null does. So if we it is a very few count, this data set only has 19 rows, so that it is easy to count the values and say only like a few cells are being empty. But if we have thousands and 2000 amount of more than 2000 amount of rows over there, it is tough to find all the data, find all the cells that are being empty. For that thing we use this function. So as we know, this data that is null actually gets to know how much data are being how much null values are over there, and the sum will actually sum up all those unavailable data and return us the values over here. So here we could see the gender column doesn't have any kind of no null values over there, so it's returning 0. And if we see height has two null cells, so it is giving us the value 2, and the same applies for the weight. So in the weight column we have 2 cells that are being empty. This is what this function is null.sum used to do. Right now we are going to split the data. So splitting of data, we could see that let us get into the data set over here. We could find this height and weight are being in the same format, and the gender is being in another format, because this height and weight over here we could see that which being in the same data type as being float, we have to separate height and weight into into one kind of data set, and the gender into other data set. So over here we are splitting it. So we are storing the height and weight into our x variable, and we are splitting out the y variable, I mean the gender column, into a y variable. So over here we could see we have did index location, that is nothing but the I log. We are splitting the data set using the I log, that is the indexed location. So over here we are selecting the first we are selecting all the rows, and we are getting only the columns from number 1. That is nothing but over here we could see that the first 0th column is gender, and the first column is height, and the second column is the weight. Over here I mentioned 3 just because it doesn't take the third column, it takes only till second column. So over here we are taking the first and the second column is being selected, and we are taking only the values. So it is required to specify dot values over here. So the height and weight are being transferred into a x variable, and the same applies for the y variable, where we are mentioned all the rows are being selected, and -3 is nothing but from the last we are selecting the third column, that is nothing but from weight, which is -1, and the height would be -2, and the gender would be at -3. So we are selecting the gender column, and we are taking that thing and placing into our y variable. That's what happens over here. And if we want to verify if it is being done, we could run the cell by printing out the values over here. If we see print x, we could find all the float variables over here of height and weight. And if we go with the y, over here we could see that Over here, when we print the y, we could see that the male females are being separated. So y variable contains all the values that are being present in the gender column, and the x and the x variable contains the height and weight values. So we have splitted it, and right now we are going to use a particular function known as the simple imputer, where we are importing from the package known as sklearn. So sklearn is nothing but scikit-learn, which is actually a predefined machine learning model in Python. So over there, a lot of things are being included in that particular thing. We are only importing the simple imputer over here. So we are calling that function into or placing that function into a variable known as impute. So over in this simple imputer, we are going to perform certain function for only for certain values. Where we are doing is, for in simple imputer, inside the braces, we have placed this missing value, where the missing value, we are replacing all those missing value, which is actually missing values is nothing but the np.nan, that is nothing but numpy dot not a number. We are replacing all those values by mean value. So we have used strategy, which is nothing but how we are going to replace all those values. What values are being replaced over there? We are using the mean values over there. So we in the data set, we could see that we have this none values. All these none values are going to be substituted or being replaced by a mean value of it. So over here, what we are going to do is, we have actually placed this whole function into this variable known as impute, and we are going to fix this thing into certain columns alone. So what columns? In the x column, we have this x variable, where in that thing we are going to place it for only for height and weight, because we have only two columns. We are going to place it for two columns over here. As I said before, the 0th column is going to be the height, and the third column will not have the third column. We are going to have the second column, that is nothing but the weight. So we are going to replace all the none values over here, and when we run this cell, you could actually see that we don't have any kind of null values over here. If we want to verify it, let us replace this print y as print x, where we could see that actually, let us run the cell. Over here, we could see that certain null values are being present, and these null values are being replaced over here. See, over here we don't have any kind of missing values. It's being replaced by a mean value over the places where the values are not being present. And right now we have replaced, and we have handled we have handled the missing values. Right now we have to handle the numeric. We have to convert the string values into a numerical form. Over here, we are using the label encoder, where it is being imported from the scikit-learn. Over here, we could from that package, we are importing this label encoder. So we are calling that function into a variable known as label encoder, and we are fitting that label encoder into our y variable. So we could see in this line, we could understand that thing over here, that fit underscore transform. We are going to fit and transform it in the variable known as y. So we are storing it in the same variable because we are going to use that thing. So when we right now, if I run the cell, after running the cell, and let me print the y variable. Right now we could see that before it was male and female, and right now it is being replaced with zeros and ones. For male value, it's taking as 1, and for female values, it's taking as 0. This is how it is being replaced. The string values are now being replaced with the numerical value, and the machine won't understand, okay fine, this is one category and this is another category. It's going to understand in that way. Now we are going to split that data into our x train and y train, and x test and y test. Over here, we are using the same scikit-learn package, where we are going to only import this train test and split. Actually, as the name is mentioned over here, the train test and split, we are going to split all those data set into a training set and testing set. Over here, we have 4 variables, that is x train, x test, y train, and y test. We are going to split these data set using this function train underscore test underscore split. Over here, we are going to split 2 variables, that is x and y. As we have taken the x and y over here, actually we split it from the data set and we have placed it in the variables x and y, and the test size is going to be 0.2. That is nothing but 20 percentage of the data set. We are going to turn it into the test set, and the random state is equal to 1, and we are going to do that thing, because always the test sites need to be below 30%, because if we go beyond 30%, there could be a chance that the data set could be overfitting, and the values or the prediction that we make would not be accurate as possible. So we are going to reduce the test set to 20%, so that it doesn't overfit, and our prediction could be as output that we are going to get would be much more precise or much more standardized. And also we are using over here the standard scaler, where we are going to standardize or normalize, or we are going to scale the values over here, because here we are only having about 19 columns, right, I mean 19 rows. But if we have a lot of rows, if we have thousands, 2000s, or more than that, it's necessary that we have to normalize the values, because if we have values from a certain range, it could be easy for us and easy for the computer, and the prediction would be much more accurate, and we could actually avoid certain outliers that we could find. But if we are uh, not using this scaling function, that could be a chance that the accuracy that we are making, or the output that we are getting, would won't be accurate, and it could be having a certain deflections. For that thing, we are going to use the standard scalar. So over here we are going to fit it in our train, and also to our test set. So as we see, we have stored this function standard scalar into our variable sc, and over here into our x train variable we are fitting and transforming it, and in the x test we are just going to transform it. So that's what we are being it's being done over here. And if we print the set, we could see that no, it would be in certain from certain range to certain range. The same applies for the x test, and we could see y train and y test. So this is how the simple pre-processing occurs. It's nothing but no, we are going to standardize, or we are going to convert the data set into the way we want it to be. So this is one of the simple example of how we are going